Hello everybody, my name is Steve Kaz. I'm a data scientist and I'm going to take you through my recent project I just finished for Lean Six Sigma, which was reducing drive-through wait time at Chick-Fil-A using Lean Six Sigma uh, methods. So just an overview, we have our problem overview, phase 1, phase 2, phase 3, phase 4, phase 5, and the results and conclusion. The phases are DMAIC. So the problem overview is that drive-through is actually long and the wait times are actually way slower than competitors, with the average wait time being around 436 seconds, causing congestion and lowering customer satisfaction slightly. And we basically dive into what are the bottlenecks and why is the line slow to begin with. So phase 1 will include these elements. Excuse me. The project charter problem statement is 436 seconds, one of the slowest out of the competitors. The goal is to cut it to 276, maintaining accuracy and satisfaction. Two student analysts, me and my partner Jamaris, led a full DMAC, I'm going to call it DMAC cycle. Some indirect stakeholders were the customers, employees, and leadership. The scope covered all drive-through steps, the benefits, just faster, and just a better overall experience for both the worker and the customer. So here's our SIPOC. Here are the suppliers, then our inputs, then the process, and then the outputs, and then the customers, obviously being the drive-through customers. With the process being fairly short and nothing too crazy. So the voice of the customers is they want a fast service, accurate orders, friendly staff, smooth payment, minimal waiting. They're critical to quality, so our CTQs are total time, order accuracy, payment time, handoff queues. The underperformance insight, overwhelmed by high volume with them being so popular. They have an outdated layout. The traffic before ordering leads to a slow manual system. The single payment window is a bottleneck. The kitchen delays, overall slower than competitors in our data set from InTouch Insights. Moving on to phase 2. Here is our current state VSM with the steps on the left side, the value added, and the non-value added time, with the total lead time being 436 seconds or 7.27 minutes, with an efficiency of 31%. The 7 wastes are waiting, over pre-processing, motion, defects, inventory, transportation, and overproduction, which all of these are being involved in the process, which is not good. The process metrics, here are our metrics and then the values. This was calculated via Excel and through the data given through the InTouch Insights. So phase 3, here's some of our diagrams. So we have our methods, our machines, our people, our materials, our environment, and our measurement, with the main problem being the slow drive-through time. With all of these aspects playing into each other for that one main problem. The 5 whys. So whys, this is basically the questions that we ask to get to what we truly want to solve. Why is total drive-through 436 seconds? It's because of the order pile-ups. Why do orders pile up at the handoff window? Because the payment is slow. Why is the payment slow? Card readers take too long. There's only one payment reader. Why are the card readers slow in only one window? Card readers are over 5 years old and store layout wasn't designed properly. Why hasn't the equipment been upgraded? There's no capital budget requests submitted for drive-through technology. So going into Pareto chart, this is from 2023 to 2025. As you can see, 80% of the defects come from slow card reading, missing sauces, and kitchen ticket delay. Where we see above kitchen ticket delay is about 80%. Then the other two fill up the other defects, the other 20%, and then fixing the top 3 would greatly reduce delays. The root cause summary, the main causes are the payment bottlenecks, which leads to slow transactions, which leads to high demand, overwhelming manual ordering. So this just plays into the whole 436-second total time. Moving on to our future VSM. This is what we wanted to improve on based off our current state. We want to cut down a lot of the NVA, shift some of it to the VA. As I know, food preparation went up slightly, I believe by 30 seconds, but NVA got cut down a whole lot. We can actually compare that. I lied. Value added only went down 5 seconds, whereas the biggest conversion was the NVA. So it's 270 seconds or 4.5 minutes, which is still not the quickest, as I believe Taco Bell is still at like 3.9 or 4.1 or something, with their process cycle efficiency being 48%. But then again, in comparison to Taco Bell, they're more likely to mess up your order, and they don't have the same qualities that Chick-Fil-A has. So here's the before and after. For the metrics, we have total time, service time, prices, process cycle efficiency, order accuracy, satisfaction, cars per hours, and cost of poor quality. With the improvements being, or with the percentage change from these improvements being 38%, 71, 39, 2, -1, 46, and 80% to their respective values. So the Sigma solutions we did 5 using these 5 lean tools: Polka yoke, cellular layout, which is basically U-shaped to make it very easy to eliminate movement mainly. The 5 S's / pull system, Kanban, and another pull system. As the expected impact was to save time, eliminate queue, reduce missing sauces, reduce ticket delay, and keep the main line moving. So here's our cost benefit analysis done within Excel. On the left side, we have our cost, our one-time cost, and on the right side, we'll have our benefits. So in total, it costs us $2,400 for the new equipment and new standards, basically, to implement these new standards. And with that, we come to the benefits that we get from that, which total at $93,430, with our return on investment being over a 9-day payment period. Our 5-year return on investment would be 18,000%, or 18,900%, with a net annual benefit of 91,000. So explanation of expected transformation, reactive to proactive system, prepayment to remove bottlenecks, self-serve sauces, digital kitchen window sync. This makes it 38% faster total, and then it matches actually Taco Bell speed, not getting ahead, while keeping satisfaction and accuracy. Moving on to phase 5, here's our control plan with our CTQs. Excuse me. And their respective measurements or metrics, with how those metrics are going to be measured, and then the measurement method, and then the frequency, and who's keeping track of that on that frequency, and then the reaction plan. So our SOPs or training recommendations, SOP 1 would be sauce restocking, 2 would be QR prepayment, 3 would be large order staging, which is technically already implemented, but I think the large order minimum price is a lot higher than $30, which does make sense, but it varies from store to fast food to fast food. Because I feel like Chick-Fil-A, it's probably easier to get $30 worth of food due to the high quality, whereas Taco Bell, I feel like, is a little bit harder, as tacos, especially if you're getting it off the meal deals menu, or if you're doing like their box combos. But anyways, the roles would be order takers, kitchen staff, window staff, and shift leads. Uh, they'd be trained in these topics, and then the duration would take less than an hour for most. So our ongoing performance metrics, daily dashboard, weekly dashboard, and then monthly dashboard, including the following characteristics, with the monthly dashboard being one of the better, I would argue, dashboards to keep up with, as the sigma level trend and the year-over-year comparison would probably be really helpful uh, from store to store. Whereas as you go less or down in time frame, it you kind of goes more in depth within within the stores themselves, and get into like the departments of the stores. Conclusion: we achieved our goal. Our PCE improved from 31 to 48%. Maintain number one and improve accuracy. Cost of poor quality reduced by 80%. Throughput increased by 46%. Some of the key success factors and the result: we transformed Chick-Fil-A's drive-thru from the slowest drive-thru to something that could compete with one of the top ones while preserving its excellency. Here are references. The top three are our actual data references, whereas the other three were kind of just used for backup and supporting claims made in touch. Thank you for listening, and like I did for my previous ones, here's what our report's looking like, or what our report looks like. Just gonna scroll through it. Feel free to go through it. And yeah, thank you guys for listening, and I hope you guys have a good rest of your day, evening, night. And yeah, take care.